Hi, ladies and gentlemen. Wow, what an amazing space and how symbolic of our discussion today. Thank you all for being here. And I would like to also welcome our online audience, all of those that are watching online. So we're here to discuss about an emblematic project, the EV4EU, and the challenges and opportunities from the mass deployment of electric vehicles and the V2G technologies. And I would just like a brief introduction from all of you about the topic before I go on with my questions. First of all, I would like to say before we start that most of you know that in Europe, the transport sector is responsible for about 23% of the greenhouse gas emissions, and it is mostly dependent on oil. Climate actions towards net zero are gathering speed across Europe, and of course, supporting the massification of electric vehicles and aiming to achieve by 2050 the carbon neutrality as it is defined by the European Commission. However, the increase of electric vehicle poses several challenges to users, cities, and energy industry. And of course, I have to say that electric cars remain an unaffordable luxury for most of the Greeks and the Europeans, of course. So just the first comment from all of you.
Okay, thank you again. Regarding the mass deployment of electrical vehicles, I have one optimistic perspective. And for example, when someone asked me if they should buy a car, one electrical vehicle, my answer is the question is not if, the question is when. Because can be now, can be in 5 years, but for sure that we will buy one electrical vehicle. Of course, we have other technologies, but this is a question of momentum. Now, what we are seeing is that we have enough maturity in electrical mobility, in electrical vehicles, and if the people start changing for electrical vehicles, the other technologies are losing the momentum. Of course, we are talking in light vehicles. If we are talking in the bus, in long-distance vehicles, in freight vehicles, the situation can be different because the hydrogen can present some advantages. But for light mobility, if we change to other technologies, the costs of the infrastructure will be very, very expensive. And here, I think that the electrical vehicles are taking the lead of this transition for the net zero mobility.
Thank you.
Good morning. Can I use yours? Yeah. Good morning from my side as well. On behalf of Sυγγελίδης Group, I would like to thank you for the invitation. I don't know what I'm doing on a technical panel, to be honest, because I'm not an engineer, actually. However, I think it is a very important project that we participate under the leadership of Mr. Morais. I represent Citroën, who is a part of the project, but our group and the Stellantis group, which Citroën is a part of, is heavily investing on the future, which is electric mobility. So, being on this panel, which is rather technical, what my contribution would be is that we are in a very, very serious change of technology. So the future is electric. The subject of the meeting today and of all the project is a sustainable future. It's a future that will make the experience of a customer better and the affordability of electric car even better. So I think we are part of a group that is going to invest so Stellantis Group is going to invest more than 30 billion euros on new platforms, new technologies, wants to be in the epitome of future sustainability programs, etc. So we are in a very exciting future, and along the way, we'll, as a group, Sυγγελίδης Group, but also Stellantis Group, would like to assist on all this effort. So this is from my side. I will be happy to answer any questions.
Thank you for the invitation. As HETNO, we participate on this conference from the beginning, from the first year, and we would like to be proactive and serving and hosting the transportation, the transition to the new transportation. And the panel session is very important because it addresses future needs from the grid and ways of how we can work together as a team, all market actors.
Thank you very much. Last but not least.
Hello, everyone. I'm Δημήτρης Pavadaskalopoulos. I'm an assistant professor in the University of Patras, focusing on energy economics and electricity markets. Thanks a lot for the invitation in this conference, and special thanks to the coordinators of the EV4EU project. Just as an initial comment, as some presenters mentioned and stressed before, the issues of electrifying transportation and the new challenges in electricity markets and energy systems are interdependent. So we need new approaches and new ways of thinking to address the challenges and exploit opportunities in both of these fields, in transport and energy at the same time. And I'm sure this is one of the topics we'll have the chance to comment more in, during this panel. Thanks.
Thank you very much. And I would like to start by Mr. Morais, and I would like you to let us know, tell us more, because you're an emblematic figure of the EV4EU project. What are the challenges you see emerging when we enter the mass deployment phase of electric vehicles?
Yes. In fact, as I mentioned in my presentation, we have different challenges that should be addressed in different angles. As I mentioned, we should start, and in the project we are starting from this, talking with citizens, talking with persons that sell the cars, for example, talking about what is the enablers and what are the barriers to have this mass deployment. And starting for the beginning, we have this challenge in regulation. And sometimes the regulation imposes some limits in the use of these technologies. And I can give you one example that we are talking a few minutes ago. We know that one of the advantages of the vehicles is that it's a very flexible load. And this is a huge opportunity for the owners, for the system operators, for the CPOs. But if we look what happens, for example, in Portugal, is that when you go charge your vehicle, you pay for the energy and you pay for the time that you are connected to the charging station. And this means that we are blocking, by regulation, we are blocking completely the flexibility that we have in the cars. Because what happens if you pay for the time that we are connected, when you have the car at 100% of your capacity, the people receive a message and will pick the car and put the car in another place. And why we have this regulation? Mainly because the growing of the electrical vehicles is much faster than the growing in the charging infrastructure. And because of this, we need to impose this kind of rules to people do not leave the car during all day in the same parking place. But the first thing is, if we want to enable the flexibility, we should remove this barrier that we have. Another example, for example, here in Greece, the vehicle-to-grid is not allowed in public charging stations. And in the project, for example, we are developing methods and algorithms, considering technologies, considering this bidirectional behavior of the vehicles, but afterwards we go to the regulation and it's not possible. And I think that we should look in the regulation, in the needs that we have, in the needs of the system operators, and coordinate this with not only a mobility regulation, but a vision for the energy system to have a global regulation that enabled services that enable the use of mobility. I'm talking on this. We can talk, for example, in the grid tariffs. We are talking in dynamic tariffs. It's not possible. In Portugal, we are testing the coordination between vehicles and the wind to avoid wind curtailment. But in fact, this, by regulation, is not possible. We need to do a lot of things. And what we are trying to do in the project is first show that we can do, try to quantify what is the value that we have in doing this service, and afterwards we should have the entities that are in the project, is the exploitation after the project, that should show to the authorities or regulators that this is possible, have this value, and afterwards we should change the regulation. Afterwards, we have the technology challenge. And the key point here, we should improve. We have this problem of licensing that is a real problem. Sometimes, for example, in Portugal, if we want to build a new charging station, it will take 9 months to have this charging station. And we should improve this process. But the main point, I think the key point, is we should have a lot of charging stations. Everyone should have a charging station in their home, if we have garage. In the working places, we should have charging stations. But to have these charging stations, we need to find solutions, first, that should be cost-effective. Should be cheap to install. And not one charging station, but 10 charging stations, 20 charging stations. Afterwards, we cannot think that we will duplicate the grid or we will triplicate the grid. No. We should find strategies to improve the utilization factor or the time that we use the grid. And for this, we need to have this intelligent flexibility and the intelligent management distributed by the houses, the buildings, the energy communities. But how we can implement this? We need to think that we need coordination. We need information exchange. We need something that can start in the DSOs, can start in the markets or in TSOs, but we should think that everyone can participate in these services and everyone can contribute to solve the problems of the grid. And for this, we need mechanisms, we need infrastructure, we need information and coordination. Again, we need regulation to do this, promoting that everyone, when we talk in prosumers, means that we need to have a smart metering infrastructure and we need to have a communication infrastructure and rules that everyone can participate in these services. And finally, we should change the way how we are planning the grids. Because we plan the grids, and the electrical grid is completely different, for example, of a traffic grid or a communication network. Because in our smartphones, if we have congestion in the network, what we'll do is reduce the traffic and the velocity that we access to the internet. But this is not critical. In the electrical infrastructure, we cannot do this. And we can find solutions to change the way how we are planning the grid, interacting with markets, allowing and enabling these services and creating tools for the DSOs and TSOs, but mainly for the DSOs, to activate these flexibilities, to have the opportunities to communicate with CPOs and other players.
Perfect. You will let us know of smart charging innovations that come from this project, but I would like to turn to HEDNO and ask Mr. Mαγκανιώτης if the distribution grid is capable of supporting large electric vehicle shares as described in the National Energy and Climate Plan for 2030.
The answer is yes, definitely.
The distribution
the question
grid
is, the answer is yes, definitely.
Yes. the distribution grid is sufficient to meet the goals for e-mobility of the National Energy and Climate Plan for the upcoming years. We are closely examining the impact on the grid from the electrification of light vehicles, taxis, buses, heavy trucks, and ships. And we are constantly updating our 5-year network development plan. The good news is that reinforcements on the primary substations for the foreseen 500,000 light electric vehicles will be minimal. Reinforcements will be mainly required at medium voltage and low voltage network to support new supplies, which can be implemented within reasonable times. For the substations, to develop new primary substations, it requires in many cases more than 5 years. So these are the good news, that we don't have such a needs. And the greatest challenge for us are the cases which we have large amounts of loads concentrated, such as bus depots, highway stops and ports. And those cases are part of our network development plan. And so we are trying to be proactive on that.
Great, thank you about that. Now, Mr. Kavvouris, are the car manufacturers ready to support the mass deployment of EVs? And how important is the infrastructure for the development of the EV market? Is it a prerequisite?
First of all, I think in Europe, all the big manufacturers are heavily investing on the electrification for the last 10 years. As I said before, Stellantis Group has announced 30 billion investment. And having seen all the future products of the next 2-3 years and the planning of the next 5 years, all groups in Europe, especially in Europe, but also to China, for example, and other parts of the world, but all the big manufacturers are heavily investing on electrification. Stellantis has announced that from year 2025, all models that they are produced and they are newly introduced in the market will have an electric derivative. From 15% of penetration of EVs nowadays in Europe, the estimation is that by year 2030, more than 50% will be a percentage of electric cars newly sold. So
it's very optimistic.
No, it's not very optimistic, because if you see the targets that the manufacturers have on fulfilling on CO2 emissions, it's a one-way road that Mr. Morais probably knows that better than me. However, it's a complicating issue, because you said if the infrastructure is very important. There is a very simple analysis in Europe. Wherever the infrastructure is very strong, the electric market is strong. Simple as this. There is other factors as well. There is the GDP per capita, so all the countries that the electrification is, the BEV part of sales is quite high. The GDP per capita is quite high as well, like Nordics, Germany, etc. So, and when I'm saying higher, I'm talking double than the Southern Europe countries. Yeah? So it's a complicating issue. However, it looks like the infrastructure is one of the major possible ways to push BEV sales. The other critical aspect, though, is the government grants. So Europe is heavily investing on transition to battery electric vehicles by giving direct government grants to consumers, companies, and individuals that they are deciding to buy an electric vehicle. I think one of the biggest challenges, and we are touching a lot of them today, is that it's the first time in history of automotive that it is a complicating issue, the energy transition. And it needs so many, Mr. Morais explained a lot. First we have to do this, and then we have to do that, and then we have to do that. And along the way, you need to make regulators, energy providers, CPOs, DSOs, communicate together. And at the end of the day, this should be possible. And at the end of the day, it should be simple for a consumer. Because if you have a consumer here listening all this, you will say, so it's going to be impossible to reach this at a certain time. Correct me, Mr. Morais, if I'm wrong. However, we are very positive on this direction because I think is on the benefit of everybody to invest on that direction, and the products are there. So there is heavy investments on cars and car productions towards that direction. And as we see and as we hear and as we know, everybody else is doing the same thing. So I'm very positive on the results the next few years.
Sorry, just one very short question. How long do you estimate it could take for this transition to electric vehicles?
I think it's gradual. It's a gradual. I mean, it takes place already now. I mean, Greece doubled the volume that did this year. We have a similar situation to a lot of European countries. So electrification is picking up faster or better or worse from country to country. However, it is a constant growth. I think the next 2 or 3 years is going to be a tipping point, a changing factor, because we will see a lot more new platforms, a lot more new products, a constant change towards range capacities. I want to say, because it's a very good opportunity, that electrification platforms is a very complicating issue for manufacturers, because you have a platform for a segment means that it needs to be affordable and should have, for the specific segment, so a small car should have a specific range. But this should be also available for you to do it for a vast number of cars to make it affordable for consumers. So it's a complicating thing, but we are very fast moving towards that direction.
Mr. Morais, you wanted to comment on something?
Only one point, that is the advantage of these European projects like EV4EU, that is works as a facilitator, because we have in the project the regional government of Açores. We have 4 DSOs, we have a CPO, we are contacting a TSO, we have a car manufacturer, we have a ABB, that is a charging station manufacturer, and we also have BPP CPOs and the platforms operator. And one of the main things is we have all these persons in the same room and working with the same objective. And these, afterwards, these entities participate in standardization, participate in DSO entities, in TSO entities. And in fact, one of the advantages of the project is combining all of these roles and all of these expectations and looking about the challenge for each one of the players and trying to find solutions that are convenient for different countries, different realities, but also creating, again, value for the different entities that we have in the project.
I thank you for that. Thank you for that comment. I would like to ask Mr. Papadaskaloupulos if you believe that electric vehicles is an energy resource that can be harvested in other ways, for example, in wholesale electricity markets.
Yeah, I think the answer to that question really depends on the charging modes we are going to implement around electric vehicles. So if we decide to go for the traditional passive or dump charging, we just allow vehicles to charge whenever they're connected to the grid, then nothing will really change around the operation of the markets. The suppliers, our electricity suppliers, will be forecasting this demand and buying sufficient energy from the wholesale market. If, however, we go to a paradigm of smart charging and potentially V2G, already today many of the presenters explained in detail some of the advantages of this, then there will be many, many different opportunities to more actively integrate electric vehicles in the markets. There are 3 main mechanisms. One was mentioned before, it's dynamic pricing. We see now how the pricing regime also changes in Greece. So having time variable charges for electricity. The second one is, as you mentioned, wholesale markets. So through aggregators, electric vehicles with smart charging and V2G can sell their flexibility in the wholesale market and access revenues through that. And a third paradigm very recently emerged in some countries in Europe, local energy and flexibility markets, where basically the EVs flexibility can be exploited to relieve distribution grid congestion and still access sufficient revenues for that service.
Thank you. We have just more 10 minutes, so I would like to ask two questions in one to all of you. So, Mr. Morais, please give us an example of a smart charging innovation that is designed within the EV4EU project, and give us more details about what V2G technologies are and what are its benefits for society as a whole.
Yes. Regarding the charging methodologies and smart charging or vehicle-to-grid, in fact, we are exploring a lot of different things. We started by the technology of charging stations itself, but the core will be in the management of the facilities. And when I talk with the management of facilities, we are developing algorithms and methods, as I mentioned, for houses, buildings, parking lots, energy communities, and also for the transportation sector. And the main advantage is in each one of the infrastructure, we are developing dedicated algorithms considering the real needs that we have. And behind this, we are considering also not only the needs of the houses or the buildings, for example, but we are considering that we will have system operators and grid that can profit of our flexibility. And in the algorithms that we are developing, we can have simple algorithms that the owner of the house or the manager of the building will take the advantage and look for himself and save money, essentially, or can see, okay, I will reduce the emissions, but in the algorithms that we are proposing, we are expecting that we can participate in services. This means that we can take advantage of the prices. If we have dynamic flexibility contracts or power contracts, this means that the power limit that we have in our installation can change during the day, not the prices, but the power. And we consider this in the services. We consider services and coordination with renewables. We consider also the part of the management with different buildings when we are talking in the energy communities. And in fact, we are also taking in consideration the legislation. For example, if we need to participate in frequency regulation, because in some countries, we already have the possibility to have this service. This means that we should incorporate this in the management of our vehicle. And the way how we are including this is saying, I will put my battery at this moment because I expect this service in a certain level and charge the vehicle later, and I will be available to provide the service. And in fact, in the end, we are resulting in a couple of services that can be used by different stakeholders in different situations that allows the participation and take advantage of the vehicle-to-grid. We are not also only looking in this part of the infrastructure. We are looking also how the CPOs can manage the public charging infrastructure and how the VPPs can develop algorithms to take advantage of the vehicles to have put offers in the market. And the question is not how we will offer in the market. It's also how we will offer in the market and how we will provide value to the users. Because in the end, the core is in the citizens, in the users. And we should share the advantage that we have in participating in these services. We should share with the citizens. Regarding the question of the vehicle-to-grid, I think that in the point of view...
As briefly as possible, sorry about that. Just
yes,
because
yes,
we
okay.
have no more time left, sorry.
No problem.
Okay, so you're not going to continue.
Final remark regarding the vehicle to grid. In fact, in our perspective, the most important is to have smart charging. This is the first step. Afterwards, the smart charging with vehicle to grid will improve the capability, will take advantage, but I think the challenge now is enable this. This will be important in very critical situations when the system is in risk. Nowadays, what we do is activate the primary reserves, is do some curtailment or non-priority loads, and in future, we can activate the vehicle to grid. But for now, I think the main priority is activate flexibility and smart charging, and afterwards, the next step will be the V2X.
Thank you. Thank you very much. Sorry for that. Thank you. It's fine. So, Mr. Mαγκανιώτης, can you please tell us how does smart charging benefits HEDNO and distribution system operators in general?
Yes, the main challenge for distribution grid is power, not energy itself. So HEDLO can handle this new load either by increasing the investments on the grid with reinforcements, which is an expensive solution, or by having an active role on the smart charging, together with the other market players. Tariffs should not promote only green charging, but also increase the utilization of the grid for the benefit of all users. So to postpone the unnecessary reinforcements of the grid. For this purpose, we need to develop new flexibility markets. And we, as DSOs, we have to do big grid investments to increase the visibility and the control on low voltage and medium voltage level. Today, as HEDNO, we are supporting smart charging, since we are providing validated metering data for medium voltage and major low voltage customers. That are connections above 55 kVA. So energy providers can use the above metering data, which come with intervals of 15 minutes, and provide to the end customers dynamic tariffs and steer them to green charging. To resolve the congestions of the grid is something that will come in the next years. It's, but at least for green charging, the means are there, so we can use them.
Thank you very much. And now, Mr. Kavvouris, a difficult question, I think, but we will see, depending on the answer. So when do you estimate that the first V2G car will be available in Greece?
It's very easy, actually.
It is.
I don't know.
I'm glad.
Okay, let me be more specific. No, I think all including Stellantis, everybody's working on a V2G ready car. So my estimation is that some model will be maybe even inside 2024 available in the market. As you understand all this, because it is also an issue of competitive advantages within the OEMs, it is actually quite confidential, so I don't even know all the technical details on this. My estimation is, though, that everybody's working on it, and we should expect 2024, beginning of 2025, cars available that can cooperate on all this program and system.
We're glad about that, and thank you for the answer.
It was not very difficult.
Not very difficult. True. And last question for Mr. Papadaskaloupulos. I would like you to tell us a few words about the complications that V2G technology brings to the EV market participation.
Yeah. Just two introductory notes on that. First of all, when you have an electric vehicle with smart charging and V2G, this is basically equivalent to battery energy storage. I think it was mentioned before by Ms. Doku. So the complications that apply to V2G market integration, they also apply to battery energy storage, more or less. And I'm saying that because, as it was mentioned before, there is a huge now momentum around battery energy storage in our country and elsewhere. So we need to keep these two issues together in our mind. The main complication, I mean, there are a lot of issues. Unfortunately, we do not have too much time to cover those, but the main issue with integration of V2G in the electricity market is that currently the market design, not only in Greece, but in general in Europe, it doesn't fully recognize the distinctive operating features of battery storage. And these are basically two. One is that battery storage can be both a generator and a load at different time periods. And also that its scheduling operation is basically characterized by time coupling. So whatever you decide to do with a battery at one time period, it affects and it is affected by how you operate it in other time periods. This is not fully captured right now in our electricity market design, and we need to take some actions in order to improve that. And having said that, just as a final note, because sometimes, especially in Greece, we tend to blame always the central authority if the market doesn't work. We need to recognize that all market players need new approaches and new tools around their market participation. Capturing these distinctive features, these distinctive operating features of V2G and battery storage, I think this is a crucial challenge going forward in the next 5 years.
Thank you very much. Thank you all of you for the great discussion. Thank you very much.